afternoon, Dr. Rosado. Today I will be performing the lab determination of experimental molar mass by freezing point depression. Alright, so our objective is going to be to determine the freezing point of the pure solvent, paradichlorobenzene, and to determine the freezing temperature of a mixture of paradichlorobenzene and naphthalene. We will calculate the freezing point depression of the mixture and calculate the experimental molecular weight of the solute naphthalene. Alright, so for our pre-lab questions, what is the formula and molar mass for the solvent to be used? Draw the chemical structure. So paradichlorobenzene will be C6H4Cl2 and the molar mass is 147 grams per mole. The chemical structure is as stated in my lab notebook. Now number 2, what is the formula and molar mass for the solute to be used? Draw the chemical structure. Naphthalene is C10H8 and the molar mass is 128.17 grams per mole. And our chemical structure is as shown in my lab notebook. What is the normal melting and freezing point for the solvent to be used in degrees Celsius? Paradichlorobenzene's melting point is 52.7 degrees Celsius and the boiling point is 174 degrees Celsius. Number 4, suppose the acid starts to freeze before you have been collecting data. Explain what you should do to solve this problem. What you would do is to take the original freezing point minus the T2, which is the ending freezing point, input the freezing point depression constant, which is Kf, into the equation and input the mole concentration into the freezing point depression formula. Solve for the ending temperature, which is T2. Number 5, what is the Kf, the freezing point depression constant, for the solvent being used with the correct units? Our solvent is paradichlorobenzene and that is negative 7.10 degrees Celsius per mole. Number 6, what should happen to the temperature of the substance while the substance is melting and why? The temperature should increase because the heat breaks the bonds within the substance, causing its property to shift from solid to liquid. Number 7, if 10 grams of ethanol, C2H5OH, is dissolved in 100 grams of pure water, what would the boiling point and freezing point be for this solution? First, determine the molality of the solution, and with Kb being 0.512 degrees Celsius per mole, and the Kf being 1.86 degrees Celsius per mole. So first, I'll calculate the mole, which is moles of the solute over kilograms of the solvent. So I'd first find the moles of the solute, which would be 10 grams over 46.048 grams, which is the molar mass, and I would get 0.217 moles. So then I would find the molality. So I put that 0.217 moles over the 100 grams converted to kilograms, which would be 0.1 kilograms of H2O, and that would be 2.17 moles. So for the boiling point, I got 0.1111 degrees Celsius, and then for our freezing point, I got 4.036 degrees Celsius. Now for my materials, I have a ring stand with clamp, 6.50 grams of paradichlorobenzene, that's in its original state, 150 grams of naphthalene in its original state, a large wide mouth test tube, and I included a funnel because I have no wide mouth, 250 milliliter beaker, crushed ice, and I'll be keeping that in the freezer until it comes time. A stovetop pot or 400 milliliter beaker on a hot plate. I'll be using a pot in my stovetop because I do not have a hot plate. And a balance, 2 thermometers in degrees Celsius, a videotape, which is my iPhone, gloves, goggles, and I am properly dressed for this, closed-toed shoes, long pants, all of that because we are working with hazardous chemicals. And now for those hazards. Paradichlorobenzene will cause eye irritation and is suspected of causing cancer and is toxic to aquatic life. Naphthalene is harmful if swallowed and is suspected causing of cancer, toxic to aquatic life. And that is why we will not be dumping it down the sink so it does not hurt our aquatic life or any living creature which it might reach. My resources are formally stated in my lab notebook, but some of those would be our pubchem.ncbi.nlm.nhi.gov and csus.edu. All right, and then now to our procedures. All right, so for my procedure, I will begin by putting my gloves on. I've already done so. And I would use plastic weighing paper to weigh out approximately 6.50 grams of paradichlorobenzene and record. All right, so it is tared to 0.00. And now I will add the paradichlorobenzene. All right, we are perfectly at 6.50 grams. All right, now I will carefully place all the parabenzene into a dried, wide mouth test tube. And I've got it on its stand right here. Alright, and now I'll use one sample of paradichlorobenzene for parts A, B, C, and D. So I use the same amount for all parts of the experiment. Create a hot water bath using your soapstop and a pot. The temperature of the water should be no greater than the melting point of the solvent, paradichlorobenzene. Alright, montage. Alright, I'm going to go ahead and leave this thermometer right here and suspend this in the water. So what I'm going to do is I have it below the water line so it fully submerges. And I'm going to check to see when it starts melting. Alright, it is fully melted. From that, it was more of like a cloudy substance. When I first put it in, it was a cloudy solid. And then the liquid is very clear, and now it's a clear liquid. Alright, so I'm gonna go ahead and take some pictures. I didn't take any before pictures. Okay, so now I have my 25 milliliter beaker filled with crushed ice, my paradichlorobenzene right here suspended over it, and place the test tube with the melted solvent from part A into the ice bath. Begin recording time and temperature readings every 60 seconds until the solvent is completely solid. It was 58 degrees Celsius, the solution, and then the ice was 15 down to 3 degrees. So 48 degrees Celsius should be at freezing point. All right, so now I'll remelt the solvent to use in part C, and then the solvent must remain completely melted to perform part C. So on to the melting. Okay, so I'm going to bring this back over here, reset my timer, and currently my water is at 72 degrees Celsius. We will head on to part C while this is melted. Okay, so now for part C, I'm going to weigh the naphthalene. I'm going to weigh out 1.5 grams of that on my scale, my balance. All right, 1.5 grams. Here we go. It's going to be need to watch it very closely. All right, that's 1.54. Okay, 1.51 grams. I'm going to add this to my solute. There we go. Perfect. All right, so we are back in action. All right, part C, add the headplane to it. Stir gently to mix. Next, I'm going to repeat part A, steps 5 through 14, and I will go to my stove. Okay, so as this heats up, I've started learning more what to do. So I'm going to get my starting temperatures down. Actually, what I'm going to do is I'm going to go ahead and drop it into the bath. Now, we go back to freezing. Okay, so I'm going to record my temperatures before freezing. I might add some more ice just to make sure that we are fully in this. We are fully doing this. It's taking a lot longer to freeze now that we've added the solute. That's what I have begun to find out, because the last one I did not have to wait this long with just the solvent. Fully frozen. It's fully frozen. So now, since I've got all that, we will move to part D right now. So in part D, we'll repeat steps part B 1 through 6, and then which we've just done, and we will remelt the solution for proper disposal as described in the cleanup. So now we will start disposing of this, and we must start by melting it down, because there's a very specific cleanup process for this. All right, that's the refrigerator, just leave it be. All right, I'm back to melting, and what I'm gonna do is I'm going to see at what temperature it melts completely, just to compare my results from the last melting. All right, and it's fully melted at 51 degrees, 51. So, okay, now that my solution is completely melted, now I will start the cleanup process. So, what I will first do is remove the thermometer and wipe it with a paper towel coated with acetone. Now pour molten mixture into a specific waste container, can or milk carton. Those are the pots. Do not pour in the sink. So now I will pour this into a can. It is covered up for other reasons or school appropriate reasons. I will rinse the test tube with small amounts of acetone, pouring this waste solution into the appropriate waste container until the test tube is clean. No sink. So we're back to our container. Then I'm going to dry off the test tubes and beaker with distilled water. All right, and I will clean up there. Now everything is cleaned up, and now I will get into my results. Okay, so for my results, in part A, where we just dealt with the paradichlorobenzene, in this one we tested the melting. So mine qualitative analysis was it started out as cloudy and crystal solid. And then it was a clear liquid once melted and reached melting point very quickly. My melting starting temperature was 23 degrees Celsius. After 1 minute, 30 degrees Celsius, then 41 degrees Celsius, 47 degrees Celsius, 55 degrees Celsius, and then finally 68 degrees Celsius as the melting point. My water was 75 degrees Celsius. Now in part B, we again dealt with just the paradichlorobenzene. My qualitative analysis was it went from a clear liquid to a cloudy crystalline substance and sticks to the side of the test tube. My freezing starting temperature was 58 degrees Celsius, then it went to 52 degrees Celsius, 48 degrees Celsius, and my freezing point was 48 degrees Celsius. And the ice was 3 degrees Celsius. It wasn't a perfect freezing temperature for water because it had been sitting out. Now, for part C, we dealt with the solution of paradichlorobenzene and the naphthalene. And my qualitative analysis was the ice went from a solid cloudy crystalline appearance to a clear liquid. And when I mixed the solution together, it was a clear liquid. But this qualitative analysis was from when I melted it and then froze it and then melted it. So my freezing starting time was 47 degrees Celsius. Then I went to 37 degrees Celsius, 31.5 degrees Celsius, 30 degrees Celsius, and the freezing point I found was 25 degrees Celsius. Now, my melting starting temperature was 23 degrees Celsius. and then it went to 26 degrees Celsius, 30 degrees Celsius, 41 degrees Celsius. My melting point was 51 degrees Celsius. My water was again 75 degrees Celsius, and the ice was 3 degrees Celsius. And that is my results. Now for my analysis, found the mass of the solvent was 6.50 grams. Mass of the solute was 1.51 grams. The original was to measure out 1.50, but I did have 0.01 grams extra, so I did put that into my calculations. My experimental freezing point of solvent is 48 degrees Celsius. My experimental freezing point of solution was 27 degrees Celsius. My freezing point depression was 21 degrees Celsius. So that was the difference between my solvent and solution freezing points. My molality was 232.3 molals. Moles of solute was 0.012 moles. Molar mass of solute experimental was 125.83 grams per mole. Molar mass of solute, the accepted, was 125 grams per mole. My percent error was 0.65% error. Now I had to sketch 2 cooling curves using Excel, and be sure to label your axis and curve. Identify the experimental melting and freezing points. So the title of mine was Experimental Cooling for Paradichlorobenzene and paradichlorobenzene plus naphthalene, which is the solution. And on my vertical axis, I put temperature in Celsius, horizontal time in minutes, and I labeled each graph using a legend, and I labeled each of my melting points and freezing points also in the legend, and I labeled my freezing point depression as well. And there you can see it. It will be in my lab notebook for a closer look, but I did put that into Excel and then copied what was shown. So thank you very much for this lab. I had a great experience with it. It was a tough one, a lot of calculations, but overall, it taught me a lot.